In this presentation, I'm going to look at dispersal of dust from the Sahara Desert and the wide-ranging impacts of this dispersal on the environment and on people. Here, this illustrates the global scale reach of the Sahara on climate and on the wider environment. This background image of the Eastern Mediterranean shows the concentration of dust in the atmosphere blown from source areas in North Africa and the Middle East. In order to consider how and why dust can be blown away from the Sahara Desert region, we first need to consider the characteristics of the Sahara that make it susceptible to dust export. First, of course, the desert is large, hot, dry and sandy. As well as large particles of sand, smaller particles of dust are also present, and these can be blown away from the region by strong winds. Second, strong winds are present because over these low-latitude hot deserts we have descending air. This represents the descending arm of the tropical Hadley circulation and results in a high-pressure cell being located over the desert land surface. A characteristic of a high-pressure cell is the flow of surface winds outwards. It is these winds that blow dust away from the region. Several studies suggest that over 1,000 million tons of dust is blown from this region every year. So what is dust and where does it come from? Dust refers to aggregates and small particles that are less than 100 microns, or 1/10 of a millimetre, in diameter. This includes clay and silt particles, as well as bacteria, diatoms and pollen. These different components reflect what is made available on the land surface, from sparse vegetation cover, dry lake beds, and by weathering of the underlying bedrock. Weathering is a key process here, and this involves breaking up hard bedrock on the land surface into smaller mineral grains. Sandstones, siltstones, and mudstones weather readily into small particles, as do many igneous rocks. Furthermore, the Sahara as we know it today has been an arid region for maybe 7 million years, and has therefore accumulated a large volume of many different weathering products since that time. This means that there is generally a high sediment supply being available for potential wind transport. And finally, the Sahara, because of its dominant high-pressure system, interacting with other weather patterns, such as the seasonal movement of the intertropical convergence zone, shows seasonal wind flow patterns operating around its margins. These include the Harmattan winds in Mali and Nigeria, the Sirocco in northwest Africa, the Ghibli in Libya, and Kamsin or Sharaf in Egypt. All of these names refer to the same thing, namely hot, strong and dry winds that blow outwards away from the central Sahara and often carrying dust with it. Here, the Harmattan winds blow towards the southwest, carrying dust from the south-central Sahara. The dotted lines indicate the passage of the wind front. Note that it takes several days for the Harmattan winds to reach the Nigerian coast. In detail, the advancing Harmattan winds are marked by a sediment-charged dust front, which can be clearly seen both on the ground and remotely. This is called a haboob. Here is an example, in this instance from Iraq. Dust transport away from Sahara source areas is shown clearly by satellite data. Here the dust is blowing outwards in several different directions shown by the arrows, and the dust front is a sharp line advancing across the landscape. The most important dust source area is a place called the Bodele Depression in northern Chad. This was once the site of a vast lake, that existed between around 15 and 6,000 years ago. The margins of the lake are marked by a series of shorelines at different levels. The highest shoreline is indicated on this image. The former muddy lake bed is littered today with fish skeletons, and in the centre of the former lake is a large area of diatomite. This is a fine-grained, light-coloured sediment made up of the bodies of microscopic aquatic organisms called diatoms. The fine-grained mud and diatomite are ideally suited to being blown by strong winds. Indeed, the Bodele Depression is the single biggest source of mineral dust into the atmosphere found on Earth. Dust from the Bodele Depression and from surrounding source areas is blown westward across the Atlantic. Satellite data pick this up very clearly, where the optical density of dust in the airstream can be measured and mapped. Here, Saharan dust travels for thousands of kilometers towards the Caribbean and the Amazon basin. There are wide-ranging environmental impacts of this dust export. In the atmosphere, dust can act as cloud condensation nuclei, encouraging rainstorm events, where the raindrops are stained red with the dust. This is informally known as red rain. Atmospheric dust can also increase lightning frequency and lead to low visibility near the ground. Dust can be deposited on the land surface in either wet or dry forms. Wet deposition by rain can give a red residue over windows, cars, plants, and anything else on the land surface. Dry deposition contributes extra sediment as well as minerals and nutrients to the soil where this dust settles. 40 million tons of dust from the Sahara is deposited in the Amazon basin every year, and this is vital in providing trace elements and nutrients to its soil. Indeed, the Amazon rainforest wouldn't exist in the way it does today without this dust input. Dry deposition also takes place over glaciers in the European Alps and can be identified as thin sediment layers within the ice. Dry and wet deposition can change water acidity and other chemical properties, and also add extra nutrients that can promote the growth of aquatic organisms. Impacts on people come about mainly by changing air quality. High dust concentrations and the presence of bacteria and other organic components can increase respiratory problems, cardiovascular disease, pneumonia, and hypertension. Changing optical effects in the atmosphere, red sunsets, gusty and hot winds, and red rain events were seen as evil portents in the medieval period in Europe, but more positively in providing inspiration for artists. Dust export has also changed over time, as is shown in European ice cores and in documentary records. Increased dust fluxes took place during drier periods in the 13th, 14th, and 16th centuries in particular. In summary, dust from the Sahara can travel thousands of kilometers from source and affect people and the environment in different ways right across the Northern Hemisphere. This dust transport is driven by the distinctive wind regimes of the Sahara, similar to those found in other hot deserts. This dust export means that the Sahara is not remote and isolated, but is connected to the global climate system. Dust is a physical expression of these global-scale teleconnections.